Hey everyone, and welcome to Mr. Ahmed's Math 20 class. Today we're moving on to the subtopic 1.3 of Chapter 1, which deals with rate of change. Okay, so far all we've been doing is kind of taking a look at slope and grade and pitch and rise over run. What you need to understand is that rate of change is pretty much the same thing as all of that. Rate of change is really a description of slope as well. Okay, so um, here you go. Here's the formula for the slope using 2 points on a graph. Okay, so you've got, for example, 2 points on this graph right here. Well, you've got more than that, but if we were to pull 2 points off of this graph, um, you've got, for example, let's say this is point 1 and then this is point 2. The way you'd figure out the slope of this line is by taking y2 minus y1 and dividing by x2 minus x1. Okay, now I know that that looks a little weird, but really what y2 minus y1 means is that if this is point 1 on your graph and this is point 2 on your graph, then what is the y value that point 1 has? So again, a reminder that y is the vertical aspect of any graph. So it would be this right here. So this is your y, and then this is your x. Okay, so y is really a representation of rise, really, and x is a representation of run. So if our point 1 is right here, its corresponding y value is 0. And if our point 2 is right here, its corresponding y value, so y2, is 4. So y1 is 0, y2 is 4. So this would be 4 minus 0. Now this is divided by the run. So again, this is a formula. This is the formula for slope, right? So you choose 2 points on the graph. So x2 minus x1. We said that this was your point 2, and this is point 1. So x2 would therefore be 4, and x1 would be right here 0. So this would also be 4 minus 0. So here you've got 4 minus 0 over 4 minus 0. That gives you 4 over 4, and 4 divided by 4, or 4 over 4, that's the same thing as 1. A slope of 1 means that for every vertical rise of 1, you're going a horizontal increase of 1, right? So every vertical rise of 1, horizontal 1, 1, 1, vertical 1, horizontal 1, and that's kind of what happens here. You can see that you're going up a vertical rise of 1 for a horizontal run of 1. Rise of 1, run is 1. 1, 1, 1, 1. Okay? So that's what this little formula looks like, or means, is that if you have 2 points on a graph, I know, again, we've got more than that, but I'm just trying to choose 2 points on the opposite ends of this line. If you got 2 points on a graph, here's the formula for figuring out the slope of that line. Okay? Now, if you've got a graph that's rising, the slope of that is positive. Okay? However, if you've got a graph that's decreasing, or where the line is going down, the slope of that is negative. And for example, if I was to take a look at this line and determine its slope, I mean, I could still use this formula right here, but again, a reminder that this formula really just means rise over run. So here I can see that from point 1 to point 2, I dropped vertically 3. Now a vertical drop of 3 is negative 3. Okay, is represented as being negative 3. So again, this is a vertical drop of 3. That's represented as being negative 3. And then here, you've got a horizontal increase. So let's see how many that is. That's 1, 2, 3, 4, 5, 6. So it drops by 3, and it goes over by 6. If I was to write that down as slope, that would be negative 3 over 6, which is really negative 1 over 2. That means that for every one that this line drops vertically, so every unit that it goes down vertically once, it'll go over 2 to the right. Oh, there you go. 1 down, and then 2 to the right. There you go. 1 down, 2 to the right. Okay, so we've got a few questions here. The questions are asking whether the slope's positive or negative. It's pretty straightforward to tell which one is positive. Anything that increases is positive. So yeah, you can expect this to be positive and that to be positive, and the ones that are negative are going to be the ones that are dropping. Okay, so as soon as your rise is negative, that means it's going down. That's where you've got a negative slope. Okay, and then calculate each slope as a fraction. You'd probably want to use this just for practice. So m equals y2 minus y1 over x2 minus x1. And again, a reminder that x1, y1 would be the x-coordinate and the y-coordinate of your first point. So here it's 0, 0, for example. And then x2 and y2 would be the x-coordinate and the y-coordinate of your second point. And if I was to choose this one, that'd be 4 and 4. So this would be 4, 4. Okay? You probably want to do that, or you can even just take a look at the graph itself, and you can probably kind of figure out what the slope is here. You can see that it went up, for example, from 0 to 3. Okay, so it's from here, from this point right here to this point right here, your graph went up vertically 1, 2, 3. So that's the rise, which is 3. Your run is 1, 2, 3, 4. So that's where 4 is. So this slope right here is 3 over 4. Okay, because it went up 3, 4 to the right. Okay? Okay, so they do provide you with the solution here. So as we just saw, that's 3 over 4. Okay. This one here, so you go, I mean, you can see that you rose from this point here to this point here. So you just rose from 5 to 10. So your vertical rise is from 5 to 10. That means it rose by 1, 2, 3, 4, 5. It rose by 5 units. So it went up 5 for 1, 2, 3 to the right. So your slope here would be 5 over 3. A rise of 5 for a run of 3. Okay, and that's what they'll do right here. Okay. Now for C, this one here is dropping. We said that this is a negative slope, and that would be because its rise is actually negative. That means it's actually dropping. Okay, so it goes from 10 down to 5. Okay, so you see how this point here has a y value of 5, and this point up here has a y value of 10. So it actually drops by 5. So we can say that's negative 5, and it goes from 0 to 9. And I can see that this is 9 because it's one right before 10 there. Okay, so it dropped by 5 vertically, and then it goes horizontally 9. So here your slope is negative 5 over 9. And there are no common factors here, so negative 5 over 9. There's no common factor here, so you would have to just leave it like that. Okay? So build your skills. That's it for you guys to try out there. Okay? And then working with slope as a rate of change. So if you're traveling in a car and you're going at 50 kilometers per 1 hour, that's a rate of change. That means that for each 1 hour, you're traveling 50 kilometers. So if we were to, for example, follow this rule, that means for 2 hours, you travel 100 kilometers, okay? And in 3 hours, 150 kilometers. So you can already tell that this is actually an expression, like this thing right here is an expression of a slope, okay? That's just, it's a rate of change, okay? So here, you've got distance traveled per hour, you've got 75 kilometers per hour and 50 kilometers per hour. In the bottom here, you put the hours. And then here you put the kilometers. Now, the bottom value here, this is what's called the independent variable, okay? And what that means is the independent variable is really, it's the thing that you have control over, okay? So the dependent variable in this case is time. Not that you have control over time or you're like some superhuman whatever, but I mean, you decide, like if this is distance traveled per hour, well, you're the one who's deciding how many hours you're traveling, right? So that's why I'm saying this is what you have control over, okay? So this is your independent variable. Now, this right here is your dependent variable. This value depends upon your independent variable, okay? So these things right here depend on how many hours you decide to travel, okay? So that's why you call the y-axis. This is why the y values are the dependent variables, because 100 kilometers, for example, depends on, or the distance you travel depends on how long you've been traveling, okay? Now, uh, this slope or this line right here has a rate of change or a slope of 75 kilometers per hour. So you can expect that it would go up 75 for every 1 hour. And once again, from up 75 for every 1 hour. And then up 75 for every 1 hour. Okay? Now, this rate of change here is 50 kilometers per hour, so you're expecting it to travel, an increases of 50 kilometers each 1 hour. So here, you're going up 50 kilometers for 1 hour, up 50 kilometers for an hour, up 50 kilometers for an hour, and so on. Okay? So again, rate of change and slope are pretty much really the same. Very important for you to be able to identify, understand that this is the independent variable. This is the variable that we control for, if you want to really explain it, this is the variable that we control. And then this is the dependent variable. This variable depends upon time. Okay, so distance will respond based on how many hours you decide to travel. Okay, and not vice versa, right? Like time doesn't depend on how far you've traveled. It's more how far you've traveled will actually depend on how much time you've been traveling. Okay. Okay, so that's kind of what they were explaining here. Time is the independent variable, and distance is the dependent variable. Okay. So Willard works as an electrician's assistant, earning $12.25 per hour. What is the dependent variable? Write an equation that shows the relationship between hours worked and income. Okay. So here's what they wrote down as an equation where E is Willard's income and H is the amount of hours he worked. Now, looking at this, you can probably tell me which one's the independent variable and which one's the dependent variable. So you can see that this one right here would be the independent variable because Willard chooses how many hours he works, right? So this is the independent variable. Now the variable that depends upon the independent variable is the dependent variable. That means that E would respond as a result of however many hours Willard worked. Okay, so whenever you're trying to figure out how much money you make, obviously you just take your wage, so $12.25 per hour, and then you multiply it by hours to get the amount of money you made. So here's here's a little the equation to show this. Okay. Now B asks you to graph the equation. So here's the graph of the equation. Okay. So again, your independent variable, your dependent variable, Willard's earnings, his money, the money he makes, depends on the amount of hours that he works. Okay. And as you can actually see, so you can expect that after 1 hour of work, he'll have made 12.25 $12.25. After 2 hours of work, he'll have made 24.50. Sorry, yeah, $24.50. Okay, so you can see that it goes up by 12.25 for every 1 hour, up 12.25 for every 1 hour, and so on and so forth. Okay. So what is the slope of the graph and what does it represent? I think I pretty much just said that. The slope of the graph is the rate of change. It is his wage. Okay, so it is how much money he makes. So $12.25 each 1 hour, that is the slope. Okay, so it represents his earnings per hour. Okay, so how much will Willard earn in 5 hours? So again, when you're trying to figure out how much money Willard makes in 5 hours, it's pretty straightforward. You take how much money he makes in 1 hour. So here's your equation again. Okay, he makes $12.25 in 1 hour. Therefore, how much does he make in 5 hours? So obviously, you take $12.25. Okay, you multiply it by 5 hours to figure out how much money he made in 1 hour, which is $61.25. Okay. Then finally, E asks, if he earned that much money on the job, how many hours did he work? Well, if this is the total amount of money that he made, and he makes $12.25 each 1 hour, then what would you have to do with these two numbers? And the answer is that you'd have to take how much, like the total money that he made, and divide it by how much money he makes in 1 hour. Okay, so total money he makes divided by how much money he makes in 1 hour, that would give you how many hours he worked. There you go. So divide, so 183.75 divided by 12.25 gives you H, so he worked 15 hours. Okay, so a few more questions for you guys to try out. Then we move on to example 3. So here, Reg timed himself jogging on a race course. He passed the 300-meter point 1.5 minutes after starting, and the 600-meter point after 2.8 minutes. So if you were to show this on a graph, you'd have to figure out what is the dependent variable and what's the independent variable. Okay, so again, a reminder that your independent variable goes in the x-axis. Your dependent variable goes on the y-axis. And the reason that's the case is because Reg would, like when he's timing himself jogging on his race course, the distance that he's traveled, so 300 meters or 600 meters, that distance depends on how long he's been running, okay, and not vice versa, okay, like how long he's been running does not depend on the distance that he's traveled. So you can already tell that doesn't really make sense. How long he's been running does not depend on the time that how long he's been running does not depend on the distance that he's traveled. However, the distance that he's traveled depends upon the time that he's been running. Okay, so this is your dependent variable. So meters, the distance is the dependent variable. Time would be your independent variable here. So you just show this on a graph. You would just make a graph, and then you'd graph those 2 points. So at 1.5 minutes, he's at the 300-meter mark. So there you go, at 1.5 minutes, he's at the 300-meter mark. And then at 2.8 minutes, 2.8 minutes, something around here, he's at the 600-meter mark, okay? And what was his average rate in meters per minute for this portion of the race? So really, it's really asking you pretty much what's his speed or what's his rate of change, right? Like how many meters is he running each minute, and that's a rate of change. So you could pretty much translate that into this question is asking, what is the slope of this line? Okay, so to figure out the slope of this line, you can use your m equals y2 minus y1 over x2 minus x1 formula, and that would work. That would be the way to do it. So y2 minus y1, so you would choose this point up here as being 0.2, and you could choose this point down here as being 0.1, okay? And that's what they do here. So x2 and y2, those are the coordinates for 0.2, where x2 would be the time, and y2 is the distance. So at 2.8 minutes, he's traveled 600 meters. Now this is 0.1, so x1, y1. So here it was at 1.5 minutes, which is your x, he's traveled 300 meters, which is your y. So there you go. Y is 300, x is 1.5. 600 minus 300, and you just set it up like that, over 2.8 minus 1.5 gives you 300 over 1.3, and then you just divide the two to get 23.1. Okay, so this is actually a little typo right here. It's 300 over 1.3. But if you really wanted to express this as a slope, you would have multiplied the bottom and the top by 10. Sorry, as a fraction, you would have multiplied bottom and top by 10, then this by 10 as well. So that should have been 3,000 over 13. So that's a little typo right here. But really, you could have just taken 300 divided by 1.3, which is what you had here, and you would have gotten 23.1 meters per minute. So that would have been the rate of change there. So you've got a few more build your skills questions right here before you hit the practice your new skills. Okay, so you've got, again, all of this stuff I'll be putting up on School Zone with the link to this video, as well as the answer key to all of this stuff. Now, this topic is pretty much the last topic in this chapter. So this chapter, which is the slope and rate of change chapter, it is over. So you guys can expect your test rather soon. I do highly recommend that you do the chapter test questions as well. So I'll provide you with a key for that as well But you definitely do want to try your hand at these questions right here. Okay, so those are, pages 57, 56, 55. Okay, so you make sure that you do those chapter test questions, and as well as the practice your new skills questions as well. Okay. All right. Well, that pretty much sums up chapter 1. So stay tuned for chapter 2.1. All right. See you guys later.